this is the general idea for how the distant supervision can be used to create data sets. And we wanted to try out creating one. So the first thing we had to do is actually, well, we get back to this idea that we need a lot of information in structured data, some kind of linked data that expresses this relation, and we have a lot of examples of that. And we also need a lot of unstructured data, which is, of course, in our case, text. So basically, we're working with news stories, because that's the most plentiful data we have. So we needed to pick some kind of relation that we both know a lot about from linked data and also can be expressed very often in the news. So there's one additional requirement, and that's that whatever relation we pick between two entities, when they're mentioned in the news together, it had better usually be reflected in the article. So we can't really go and talk about one-off events or some very new developments that don't last a long time. So the decision we ended up making is to build a data set based on the subsidiary relation that basically fits all of our parameters. For one, there's a lot of data about which company owns which other company. It's very common in both open sources and proprietary data sets. So we actually had a large initial number of pairs of companies where we know for a fact one owns the other, so they do have the subsidiary relation. The other benefit is that companies are, as you all know from our poll data, one of the major things being discussed in the news. So whenever one big company acquires another important company, it's highly reflected in the news. When a company does something important, and if it's owned by some bigger entity, that's also usually mentioned. And the final step, and the one we're not entirely sure about, but we'll give examples of how it usually works out well, is that if both a company and its subsidiary or owner, whichever way, are mentioned in the same article, journalists usually catch people up to speed, because while it is common knowledge which companies own which other companies, it's not usually assumed that everyone knows this relation. So whenever an article mentions both of these companies, it's usually explicitly stated, and this one company owns this other company in some way. And what our actual task is to learn how people express this relation in news articles. So when building the data set, we ended up working with 4 distinct groups of examples. There are 2 kinds of positive, 2 kinds of negatives, so I'll just go over them. The first kind, the more important one we're aiming to learn how to discover, is there exists a subsidiary relationship between the 2 companies, and we used some proprietary data sets that are not publicly available to extract these. And we specifically targeted companies that we know have the subsidiary relationship, but it's not reflected in public sources like DBpedia. So that's the task we're trying to learn how to solve, is to discover these kinds of new relationships. The second type of positive examples are perhaps the better well-known ones, but they're ones that are subsidiary relationships available in public data like Wikipedia, and these are stated explicitly. And then we have two types of negative examples. The first and more numerous type is basically, for negative examples, we have to be sure that a relationship between the 2 companies doesn't exist, because we don't want to accidentally pollute it with companies that are related but we don't know about it, which is why we picked pairs of owner and subsidiary companies that we know that the owner owns some companies, and we know who the owner of the subsidiary is, and they're not the same company, so we know for sure this is a wrong example. And finally, we have the simplest type, perhaps, the negative type 2, which all it does is inverses the direction of a positive relationship. So if we say that Google owns YouTube, we know that's true, we know that's an example and it's publicly available information. So then we would make a negative example saying YouTube owns Google and give the same kinds of articles. Basically, these exist because the relationship we're trying to learn here is directed. And we don't just want to say, well, one of these owns the other. The algorithm needs to be able to tell which one's the parent company and which one is the subsidiary company. So then we went and collected the data, and something you'll see is, once we started with the positive type 1, these are the ones we know about from proprietary sources that are not reflected in DBpedia. We found quite a few of them, but we didn't end up with as many news articles, which is basically what that's telling us is that these less well-known examples are less written about as well. A few surprises for us when curating the data was that this proprietary data set we were using had a surprising number of inaccuracies for positive relations, but we did end up cleaning them out. Although we expected it to be higher quality than DBpedia, and what it turns out is that DBpedia already has, we found fewer examples of the relationship, but we got a lot more articles about them. Which is what you can see the difference here. So this first column tells us how many parent-subsidiary relationships we discovered of this kind, and the second column is how many news articles mentioned these companies. So we can see, despite them being slightly fewer in number, there are a whole lot more news about them, which is because they're bigger companies, they're more talked about, they were more in the public eye when the whole thing was happening. So then the negative types, I'll just skip to the end here and say that negative type 2, since it's just the inverse of the first two, it's kind of like the sum of them. Each example here has a corresponding example here in the negative type 2. The negative type 1, unsurprisingly, gives us a huge number of negative examples, which is helpful because what we really want to do with this data set is learn how to tell the two companies mentioned close together have this relationship. And of course, a lot more examples we have show two companies being mentioned close together, but not really being related in this way at all. Okay, so I'll just go over the split. We ended up with the train set. The size, this is first the number of owner-subsidiary pairs, a little over 1,000 companies, and we have over 100,000 news articles discussing these pairs of companies. As I mentioned, what mostly goes into here is the positive examples of type 2, the ones that are available in public sources like Wikipedia. Their corresponding inverses, which is what negative 2 was, and then a selection of the wrong examples we talked about that we have quite a few of. So the split for the train set is roughly 1 positive to 4 negative examples. And then we had a split for the test set, which has roughly the same number of pairs. It's about 200 fewer. But a lot fewer news articles because they aren't as talked about. And again, most of the positive examples here are things that aren't available in public data like Wikipedia. So they're not easily discoverable through other means. That's why we need to train an algorithm that knows how to do it. The big difference between the train and test set is that the relationship of positive to negative is very strongly skewed here, 1 positive example to every 10 negative roughly. So we have this situation where the train and test set don't really have the exact same split. But in a way that also corresponds to the real world scenario, as in any actual situation, we would get the biggest, most talked about examples first, and then the smaller ones we need to discover are the ones that are hidden in the noise of negative examples more.